Welcome to Homework Lib.
Okay, so here there are two stereo speakers A and B that are 1.4 meters apart. 1.4 meters is the distance between A and B, right? Now they are sending out sound of wavelength 34 centimeters. So lambda is equal to 34 centimeter. So this is equal to, in meters, 0.34 meter in all directions. So the distance between point P, where the person is standing, and the stereo speaker B is fixed, that is 1.5, and x can be changed, right? So for what values of x will this person hear maximally reinforced and cancelled sounds? So if we want, let's do first part A of the question. For maximum sound, maximum sound comes when there is constructive interference, right? And for a constructive interference of sounds, the path difference, for this we need that the path difference should be integral multiple of the wavelength, right? So here path difference is what? 1.5 minus x should be equal to n lambda, right? Now for n equals to 1, right? If you put lambda equal to 0.34, then this gives me x equals to 1.16 meters. For n equal to 2, if you put lambda equal to 0.34, then the equation gives me x equals to 0.82 meters. Similarly, for n equal to 3, the question says that we have to stay less than 1.5, right? And we cannot go below 0, and we cannot go more than 1.5. All right. So for n equal to 3, x equals to 0.48 meters. And for n equal to 4, x equals to 0.14 meters. So these are the lengths. So obviously for n equal to 5 we will have less than 0, so we don't need that. So these are the distance at which we hear maximum sound, right? So let's do part B of the question. For part B, we need cancel sound. The sound get cancelled if there is destructive interference now, right? And for destructive interference, our condition is that the path difference PD should be odd integral multiple. For this, n goes from 1 to 2n minus 1 by 2 lambda, or integral of lambda by 2, where n goes again from 1 to So again, let's do this turn by turn. For n equals to 1, or let me write this again. Let me write the equation first. So path difference equals to 1.5 minus x should be equal to twice n minus 1 by 2 lambda, right? Now for n equal to 1, If you put the value of lambda to be 0.34, then the expression gives me x equals to 1.33 meters. So this is where we cannot hear sound, the noise cancellation occurs, sound cancellation occurs. For n equal to 2, x will be equal to 0.99 meters. For n equal to 3, x equals to 0.65 meters, and for n equals to 4, x equals to 0.31 meters. For x equal to 5, it comes out to be negative, so the noise is cancelled at these distances. Alright, so we have found out the distances at which the sound is maximally reinforced and sound gets cancelled. This is the solution for this question.